Hello, my dear students. Hope all of are well and following Break the Chain and Stay Home campaign. God bless you all. Utilize this free time to study a little bit or prepare a little bit for your term and examination. So that's why I came here to have some discussion on data structures. Okay, in this video, I am discussing about uh, graph. That is one of the nonlinear data structures. In our earlier classroom lecturing, we have discussed about some of the linear data structures like stack, queue, linked list, etc., and their application, everything. And after that, we have discussed about some one of the non-linear data structure called trees. Okay, and its application areas, and we have discussed about tree traversal techniques, and we have discussed about different types of trees, everything. Now here we will discuss about graph. So graph is a non-linear data structure. Okay. So you may know what is the difference between a linear and non-linear data structure. So graph is organized under a non-linear data structure category. So graph is basically a pictorial representation of set of objects where some pair of objects are connected by links. That means there are certain objects. Some of these objects are connected by the links. That is a graph. So these objects that may be in the real life problem, that may be a city, or it may be representing certain subtasks, or anything that can be represented individually within a real life problem. Okay. So these objects, in a graph terminology, these objects are called as vertices, and the links that connects between these vertices are called as edges. So let us see an example for a graph. See here, I have drawn a graph with 5 vertices and 7 edges. So vertices are usually named just like here I have used the name A, B, C, D, E to indicate that vertices. So it should be named. Okay. So here in this graph we have points A, B, C, D, E. These points are called as vertices. And these points are linked by using edges. So see, the vertex AB, they are linked together. So they are linked together by an edge called as AB. Similarly, B and E are linked together by an edge called BE. Same way, AD, AC, and CD, BD, and DE are the different edges that are represented within this particular graph. Okay, so a graph can be mathematically represented as a set of vertices and edges. So what is vertices? That can be represented in here. It is represented as set VE. Okay, VE. Where VE is set of vertices. So in this case, it is A, B, C, D, E, and E is set of edges. So in this particular graph, the edges are A, B, BE, AD, AC, CD, DE, and BD. These are the different edges within this particular graph. So graph means a set of vertices and edges. Now let us see what are the different terminologies used in this particular data structure. That are vertices. So what is vertex? So we have discussed about it. So each node in a graph is termed as a vertex. And what about the edge? The link between the edges, between two vertices, the link between the two vertices, they are called as edge. And here we have another concept called as adjacency vertex. So let us see here the earlier graph. So A and B are linked together. So they are called as adjacent vertices. So consider, what about that A and E? They are not directly connected, so they are not adjacent vertices. Same way, AC are adjacent vertices, AD, AE, then DE, CD, everything. These are the adjacent vertices. So if two vertices are adjacent vertices, then there should be a link. Now, the another concept is the path. Path represents a sequence of edges between two vertices. For example, in this case, the path between C and E. So C and E, it is following the path, from on moving from C to E, we have to follow the edge CD and DE. Okay, so the path between C and E is CD and DE. So that means path represents a sequence of edges between two vertices. Now we have another concept, concept like directed graph, undirected graph, weighted, unweighted. So I'm just giving some brief idea about these things. Okay, see here the graph with these nodes. We consider this edge AB. So here you may have certain doubt that from where we are starting. Say we are starting from A, or we are starting from B and moving towards A. Okay, so let us see here edge, this one AB. So that has a certain direction. So you can understand that you can recognize this one. This particular edge is starting from this. That means the source node is this A and is ending on B. So destination is B. That means this edge is following A to B flow. Okay, but we haven't given any direction here. So this one, the graphs where the edges which are not represented by any direction, they are called as undirected graph, and the graph where the edges are given with the direction, they are called as directed graph. So here AB, edge AB, that means it is following, its flow is from A to B or B to A. But here it is only a one direction, only A to B, okay, like that. So that is the difference between a directed graph and an undirected graph. Only thing is that the edges will have direction in directed graph, in the undirected it will not have. Now let us see the weighted and unweighted graph. See here, it is our normal graph. Okay, edges haven't represented with anything. Okay. Now see here, the edges are represented with certain values. Okay. Assume that these particular nodes or the vertices are representing certain cities, then these values they are representing the distance between that two cities. So in this way, anything can be represented by using these values. These values are called as a weight. So for this particular nodes, the edge, that is the edge value, that is giving a weight for that particular edge. So edge is in a real life problem, the edge has certain value. Then suppose the vertices are two cities, then the edge weight value is giving the distance between two cities. Okay, or within suppose it is edge connecting two subtasks. Okay, then that weight value is giving an information regarding the time consumed for processing from that particular subtask to the another subtask. So in this way, we can give weight values for each of the edges. So if we are provided edges are provided with the weight values, then it is called as weighted graphs, otherwise unweighted graph. Okay. So this one is a weighted graph and unweighted graph. Okay, let us see some of the simple application areas where these graphs are used. Okay, all of them, we all using social media networks. Okay, so if you are using Facebook, we will get notification regarding the some of suggestion regarding new friends. Okay, so how these suggestions or notifications are generating? Let us see that one. Okay, so here the suppose this one is representing a social media, Facebook. Okay, and these are the different members of that particular social media network. You see here, Arun, friend with Ashwini, then Vivek and Joseph. Okay, same way. This Vivek is friend with Arun, then Adnan. Okay, then same way Joseph and Adnan are friends. So in this these members can be represented by graph, and by using that graph theory, it can be suggested that Arun maybe Arun suggestion can be in this way. You can have a friend like Adnan, because Adnan is one friend of your friend Vivek, and he is also the friend of your friend Joseph. Okay, same way Vivek will get notification that you may be a friend with Ashwini, because Arun is already a friend with Ashwini. Okay, in this way, by using a graph theory, you can generate any of these possibilities that can be effectively generated. Okay, similarly, here I'm using a weighted directed graph. Okay, see here the vertices, these vertices are representing certain cities, and suppose a traveler want to travel from the city 0 to city 7, and he has to follow some shortest path. So by using graph theory, you can very effectively generate the shortest path between that two cities. So here the shortest path is in this way, that traveler has to follow this particular path 0 to 3, 3 to 6, and 6 to 7. That is the least. That is the shortest path for that particular traveler. In this way, the graph has a lot of application in the area of computer science, and also in mathematics. Now let us discuss about the differences between graphs and a tree. So we have studied well about trees in our lecturing class. So here I have taken the parameters for comparison, is that path, route, loop, complexity, then traversal techniques, number of edges, and the model type. These are the parameters taken for the comparison. Okay, the first parameter, that is path. In the case of path, the trees will have only one path between two vertices. So that means between two vertices there will have a unique path. But in the graph, it is not so. It may have more than one path. Okay. Then in the tree, in the case of tree, we know that the tree traversal, everything we have studied that it is starting from the root node. So everything will start from the root node. Okay. So a tree will have an exactly one root node. But in the case of a graph doesn't have any root node. That is the difference. Now loop part. Let's see that loop. In the case of trees, the loops are not permitted, but in the case of graphs, loops are permitted. Let's see what is that loop. In the case of tree, see it is following this particular hierarchy. But here in the graph, let us see here. See this one, D, E, F, G, H. Okay, they are interconnected, and it is forming a loop. That means it can start from D and follow this path, and you can reach onto D itself. So that means it is forming a loop here. So that is permissible in the case of graphs. So, but loops are not permitted in the case of trees. So that is another difference between tree and graph. And since it will have a number of links connecting from one node to another, and another node to another, different other nodes. So the complexity will be higher in the case of graphs. but that will be lesser in the case of trees. And tree traversal techniques. In the case of trees, we have discussed about in order, pre-order, and post-order methods for tree traversal in trees. Same way, we have two different tree traversal methods. In the case of graphs, called as a breadth first search and the depth first search, and it is called as a BFS and DFS. So these are the different graph traversal techniques. So that will be discussed in another video session deeply. Okay, now the number of edges. Okay, in the case of tree, we have discussed one of the characteristic of tree is that if we have n nodes, then it will have n minus 1 edges. Okay, but in the case of graph, that type of restriction cannot be imposed. So that is not defined in the case of graphs. Okay. Then another thing is the model type. Okay, model type. So in the case of a tree, it is following a hierarchical model. Then in the case of a graph, it is following a network model. That you may have studied about this hierarchical and network models in the database management, DBMS classes. Okay. The difference is that in the case of hierarchical model, it is following one to one or one to many. That means one parent and there will have a single child or more than one child. So that means a one-to-one and or one-to-many relationship will be there in the case of a hierarchical. But in the case of a network model, many-to-many, that means there will have more than one parent for a node and then more than one child for a node. So the many-to-many will be the concept is used in the case of network model. But just I am giving a simple concept regarding this hierarchical and the network model. Okay, so trees are following that hierarchical model and graphs are following that network model. Now, how will you represent a graph? Okay, so within a white paper, you can just draw the nodes and you can draw the edges, so it will become a graph. But in the case of computer, how will you represent a graph within a computer? So there are different methods for that one, and here I am discussing only two basic methods. One is called as adjacency matrix method, and second one as adjacency list method. Okay, so adjacency matrix method, that means we are using a matrix here. We know that what's a matrix? It means it will have certain rows and it will have certain columns. So a matrix M by N, that means it will have M rows and N columns. Same way here also we are using, suppose we have to represent a graph with N nodes. We have to use a N by N matrix. So where N, that is indicating the number of edges, C number of vertices. So see here we have edges, they are labeled as 0, 1, 2, 3. So in this case the number of vertices are 4. So we have to use a 4 by 4 matrix here. Okay. So they are represented, that names are given here 0, 1, 2, 3. Or if it is A, B, C, D, E, then you can represent in that way A, B, C, D. Okay. Then suppose if we have an edge between two vertices, just like here 0 and 1, 0 and 1, there is an edge. So if there is an edge between two vertices, then we have to give a value 1 in the corresponding field, just like 0, 1, 0, 1. Okay. Since there is an edge, we are giving a value 1. Okay, see 1 to 3, 1 to 3. There is no direct edge between 1 and 3. So here we are putting 0. So an element Vij in the matrix will have a value 1 if there is an edge between that I and j, and if I and j will not have any edge, then its value will be 0. So Vij's value is either 1 or 0. Now let's see the adjacent list method. Okay, in this case, we are using a certain linked list to represent our graph. Okay, so same graph is represented here with the adjacency list method. So here we have to use a linked list as a head list. So that will have each element of that particular head list will represent each vertices of that particular graph. Okay, from E and so this one is the head list, and from each element or from each node of that particular linked list, there will have another linked list. Okay, that is representing the nodes which are connected with that particular node. So, with node 0, these vertices are connected with. See here, 0, 1 is connected with the 0, 2 is connected with 0, 3 is connected. So here we have to use another linked list that will contain the nodes which are connected with this particular vertex. Okay, same way, what about 1? 1 is connected with the 0 and 2. So we have to use a linked with the element 0 and 2. And what about 2? Okay, sorry that certain mistake is there. 2 with a 0 and 1. So 0 and 1. Okay, there should be a value 1 also. And what about 3? With a 3, it will have a connection with a 0 only. So we have a linked with a single element. Okay, so that are the two different methods for that adjacency list and adjacency matrix method to represent a graph. Okay, with that we came to the end of this particular session. So it is consider this one as a introductory video session regarding graphs. Okay, so since it is my first video session, okay, you can give any suggestion and modification. Okay, so soon you will get my second edition, second video session regarding the traversal techniques in graphs, that is BFS and BFS. Okay, thank you all.